Number 1, presidential approval. This is in chapter 10, section 10.1, comparing two proportions together. So in the state part of this confidence interval, we really need to define what we're doing for P1 and P2, because we're going to take the difference of them, so the order that we do it in does matter. So we're going to let the proportion 1 be the true proportion who approved of Obama in 2010. True proportion who approved of Obama in 2010. And you'll see why for when we use our calculator, but I'm going to write the actual proportion here. So it would be 512 over 1024, right? Because it's a 50% approval rating. So when we enter it in on our calculator to check, we're going to need to use the numbers, the actual sample numbers of 512 over 1024, which is just 50%. So just put a note. You don't normally have to write that in there, but you're going to need it for the calculator. And then, so of course P2 is who approved in 2009. So I'm going to put you wouldn't, on a test you would write it out, but for brevity here I'm just going to put in 2009. And I'm going to put, for 2009, the sample was 530 over 1,000. So in 2009 it was 530 over 1,000. Okay, so what direction, if we want to do the change, our goal is to estimate the change. So will we do P1 minus P2 or P2 minus P1? Yeah. So we want to do P1 minus P2, right? Okay. So we want to estimate P1 minus P2 at the 90% confidence level. At 90% confidence level. Okay, so that's our state. Two proportions, and so basically, let's just make sure this makes sense. So, did it go up or down? Did the approval rating go up or down? It went up. So it went down, right? It went down. How much, roughly? Yeah, so it went down 3%. So what we're asking is, though, when you take a sample, there's some fluctuation in your sample. It doesn't exactly give the true proportion of the population. So what we're asking, is that enough of a difference to know that his approval rating really did decline, or was it just, is it possible that just the samples we took made it look like it declined? So that's what we're trying to figure out, what that range of change is, to see at the 90% confidence level. So, so our plan is, the name of this would be now a 2 sample. So use a 2 sample. Is it Z or T? Z, good. Proportions is always Z. And it's use a 2 sample Z interval, or perform, or find, if our 3 conditions are met. So the random one is still the same. So if the data came from a random sample, which did it? Yeah, it says randomly selected. So that's the easy one. Now the normal condition, now this is a little bit different, but not really. What was the normal condition for proportions? And NP, N1 minus P greater than or equal to 10. So we have to do the same thing with both proportions. So for 2010, the successes and failures would both be, since it's 50%, they would both be 512. So both 512 and 512 are greater than or equal to 10. That's for 2010 And for 2009, we would do 53%, which we already know of 1,000 is 53, and that's greater than equal to 10. And then we have to show that 47%, that the failures is also greater than equal to 10, which it is, because that's 47. Okay, so you do need to show for both, okay, for the normal condition. And then the independent you also need to do for both, so the independent is was our sample size bigger than, did we sample more than, are there at least 10 times 1024 adults? Yes. So we have to do that for both. There were at least 10 times 1024 U.S. adults in 2010 and 10 times 1,000. There were at least that many U.S. adults in 2009. Okay. All right. Ready for our do part. So we're gonna plug this into the formula. So I'm gonna write out the formula so it's here. So it's just let's see. I could write it out. It's right in your notes, or we could just plug in the numbers. Why don't we just plug in the numbers? You can refer to it in your notes. So P1 hat minus P2 hat. So what's P1 hat? The proportion for the first, what is it? But yeah, 0.5. 0.5, 50%. And what's the other one? Minus, yeah, 0.53. So that's the difference in the statistics. That gives you negative 3%, right? That's going to be in the middle of our confidence interval. Okay. So plus or minus. Now we want to go in each direction, and we want to do z star. So to find that, it's a 90% confidence interval, right? So what area is left in the tails? 10%, right? And so take half of that, 5%. So just do inverse normal, and put 5% in there, and that will give you the number of standard deviations to the right and the left we want to go, to get all of those within the 90%. So that should give you 1.645. So that's the number of standard deviations we want to go to the right and the left for a 90% confidence interval. And then square root. So what is the standard deviation? Well, so you go like this. For proportion 1, it's 0.5, that's P, 1 minus P is 0.5 times 0.5 over the sample size of 1024. Plus, and then we have 53% was the other proportion times 1 minus P over 1,000 for our sample size. So if you do that, if you type that in carefully on your calculator, so be sure to try that, you should get negative 3% plus or minus 3.7%, or 0.037. So the interval is from negative 0.067, so negative 6.7% change to a 0.7 positive. So do we know for sure that his approval rating declined? No, in fact, on the upper end it could have improved by 0.7%. It could have been anywhere between it could have declined by 6.7%, or it could have improved. So we do not have convincing evidence. But we can say for our conclusion, and then I'm going to show you how to check this whole calculation that you can do on your calculator. So we would say we are 90% confident. We are 90% confident that the interval from, I'm going to write it in percents, negative 6.7% to 0.7% captures the true approval rating change. Okay, so I'll say that. And then to interpret here, is it plausible that his approval rating, there could have been no change? So yes, absolutely, right? So since 0 is included, in the interval, it is plausible Obama's approval rating has not changed. Rating has not changed. Okay, so calculator, you go to, let's just check. So what's recommended? Because if you use your calculator, you make a mistake, you will get 0 credit for the do section. But if you write out the formula correctly, and you do it this way, then double checking on your calculator, that's really the best way to do it, so that you have 2 ways to check. So let's go to, so turn on your calculator, go to stat, and then scroll over to tests. And all of the tests and intervals are under tests, even though it says tests. So we want to go to 2prop z int. So you scroll down to 2 proportion z int. It should be B, letter B. So you have to, that's the thing, is it's easy to pick the wrong one too. So you have to be really careful. So go to 2prop z int, interval, int is for interval, not integer. Hit enter. And then you simply type in the values. So for P1 it was 512 over 1024, 512 over 1024, and for P2 it was 530 over 1000. And then you just put your confidence level. You don't even have to compute z star when you do this. So we want 90%, and then you hit calculate, and let's see what we get. There's the interval right there. So between there and there, and so your calculator can tell you what the